If Betelgeuse were placed where the Sun is, it would extend to Jupiter's orbit. A monster that is totally unsteady and about to explode, it is one of the most well-known sources of radio energy throughout the universe. Betelgeuse provides more energy than 1 billion suns. In the galaxy, Betelgeuse is a red supergiant star. Assuming you place it where the Sun is, the orbit of Jupiter would be connected to it. Completely monstrous, its unpredictability and potential for explosion make it a fascinating object of study. When we think about stars, most of us imagine tiny glowing objects in the night sky, but stars are completely different from how they appear from Earth's surface. In fact, Betelgeuse is one of the most widely studied stars because it is much larger than the Sun. This star has puzzled researchers for a long time. However, something even more disturbing has been going on. Astronomers, along with other highly educated individuals, have been closely monitoring Betelgeuse. Watch this video with us as we investigate the incredible information about Betelgeuse's imminent destruction, as predicted by the James Webb Space Telescope. The implications of this new development will affect both our lives and our understanding of the universe. As explained by physicists here on Earth, Betelgeuse is an enormous star that has intrigued cosmologists for a long time. Antonius, a Greek astronomer, was the first to realize that this star was massive enough to be visible at night from Earth. If you're interested in cosmology, you have probably heard of or seen this star. It appears as an orange-reddish star in the upper left shoulder of the constellation Orion. You can see that this star is old, one of the most brilliant stars in the night sky. One of Betelgeuse's most intriguing features is that its brightness does not remain constant, it fluctuates. This variation makes Betelgeuse unique, but it's not the only fascinating aspect of the star. Stars far away from Earth can be seen in the night sky. The nearest star to Earth is 4.2 light-years away. If you don't fully understand the concept of light-years, think of it this way. Light travels at 186,000 miles per second. The distance that light travels in 1 year is called a light-year. If you do the math, you'll see that even 4.2 light-years is an immense distance, billions of miles. Now, consider Betelgeuse, which is located approximately 600 light-years from Earth. Even if we could travel at the speed of light, it would take 600 years to reach it. Our fastest space rockets are nowhere near capable of such speeds, yet Betelgeuse still shines so brightly in our sky. Why is Betelgeuse so bright despite its distance? Its size is one reason. Betelgeuse's luminosity is incredibly high. Its diameter is estimated to be around 1,000 times that of the Sun. Using modern telescopes, Betelgeuse appears as a visible disk in space, unlike many other stars, which appear as mere specks of light. Betelgeuse has a mass of approximately 12 to 19 solar masses. Astronomers define a solar mass as equivalent to 2 times 10 superscript 3 kg. Scientists are unable to determine the exact volume of Betelgeuse because no planets orbit it for comparison. Naturally, we cannot measure it directly from Earth, but we estimate Betelgeuse to be at least 12 times greater in brightness than our Sun. The brightness of Betelgeuse fluctuates between magnitudes of 0 and plus 1.6. This means Betelgeuse is significantly brighter than the Sun. It has earned the nickname Red Supergiant for a good reason. Despite its brilliance, Betelgeuse's brightness is not constant. It fluctuates as the star expands and contracts. When Betelgeuse expands, it appears brighter. When it contracts, it dims. This cycle can last anywhere from 10 to 100 days or even longer. Betelgeuse has a unique characteristic, a dark magnetic coating on its surface. Its magnetic field is far stronger than the typical stellar surface field. However, these dark spots with intense magnetism obstruct the flow of hot gas to the star's outer layers, making these regions cooler. Compared to our Sun, Betelgeuse has significantly more of these dark spots. This explains why Betelgeuse is cooler than our Sun despite its enormous size and brightness. While the Sun also has sunspots, Betelgeuse's dark magnetic spots are much larger and far more numerous. To give you an idea of their scale, some of these spots on Betelgeuse could be twice the size of Earth. Additionally, Betelgeuse's magnetic field is about 10 times stronger than that of the Sun. When observed with a telescope, the gases in Betelgeuse's outer layers appear to be curved or circular due to its intense magnetic activity. Betelgeuse's surface temperature is approximately 3,500 K, which is relatively low compared to other stars. This low temperature contributes to its distinctive red hue. However, Betelgeuse was not always red. Around 10 million years ago, it was yellowish, similar to our Sun. Over time, its color changed to orange-red, and about 100,000 years ago, it gradually transitioned into the red supergiant we know today. Scientists have concluded that as Betelgeuse ages, it produces up to 100,000 times more energy than it once did. If it were closer, it would outshine our Sun. It is remarkable that Betelgeuse, despite being 600 light-years away, can be seen with the naked eye at night. In contrast, our Sun is only 8.3 light-minutes away from Earth. If Betelgeuse were as close as the Sun, it would be so bright that we could see it even during the day. However, if Betelgeuse were to replace the Sun, its enormous size would consume or displace Earth and the inner planets. Even if it were the same size as the Sun, its immense radiation output would drastically impact our planet. Betelgeuse, also known as Betelgeuse, is a gigantic star located in the Orion constellation, approximately 600 light-years from Earth. One of its most striking aspects is its enormous size. In terms of both radius and volume, Betelgeuse is many times larger than our Sun. If placed at the center of our solar system, it could easily engulf Jupiter's orbit. Because of its legendary size, Betelgeuse appears as more than just a point of light when viewed through powerful telescopes, unlike most other stars. Despite its vastness, Betelgeuse remains one of the most fascinating stars in the universe. Betelgeuse is in the final stages of its life cycle. As a red supergiant, it has already exhausted the hydrogen in its core and is now burning heavier elements. Eventually, it will reach the point where it can no longer sustain fusion, leading to a catastrophic event, a supernova explosion. Scientists estimate that Betelgeuse could explode within the next 100,000 years, which is relatively soon in astronomical terms. When it does, the explosion will be one of the most spectacular events witnessed by humanity. The supernova will shine as brightly as a full moon and may even be visible during the daytime for several weeks or months. Will Betelgeuse's supernova affect Earth? Although Betelgeuse is enormous and powerful, it is far enough from Earth that its explosion will not pose any direct threat. If Betelgeuse were closer, say, within 50 light-years, it could potentially expose Earth to harmful radiation. However, at 600 light-years away, the supernova's impact on our planet will be mostly visual, with no harmful consequences. Despite this, the explosion will send a shockwave through space, potentially affecting interstellar dust clouds and triggering the formation of new stars. This process is a crucial part of cosmic evolution, as supernovae seed the universe with heavy elements essential for the formation of planets and even life. What comes after the explosion? Once Betelgeuse goes supernova, it will likely leave behind either a neutron star or a black hole. A neutron star is an incredibly dense remnant, only about 10 to 15 kilometers in diameter, but with a mass comparable to the Sun. If Betelgeuse has enough mass left after the explosion, it could collapse into a black hole, a region of space with gravity so intense that not even light can escape. Observing Betelgeuse today. Astronomers around the world are closely monitoring Betelgeuse for signs of an imminent explosion. In late 2019 and early 2020, Betelgeuse experienced an unusual dimming event, leading some scientists to believe that it was approaching the final stages before a supernova. However, further observation suggested that this dimming was caused by a cloud of dust expelled from the star rather than an imminent explosion. With advanced telescopes such as the James Webb Space Telescope and other observatories, scientists continue to study Betelgeuse, hoping to capture one of the most significant cosmic events in human history. Ju is not the largest star. Its mass ranges between 12 and 19 times that of the Sun. The variation in mass estimates is due to the difficulties in precisely determining the mass of stars without companion stars or other celestial bodies to provide points of gravitational reference. Still, even at its estimated lower mass, Betelgeuse remains an enormous cosmic body. Betelgeuse's brightness is another important characteristic that fluctuates over time, ranging in magnitude from 0 to plus 1.6. For contrast, a star with a magnitude of 0 is approximately 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be up to 1,000 times more luminous than our Sun. Its pulsations cause fluctuations, sporadic expansion and contraction, due to internal processes within the star. When Betelgeuse expands, it appears brighter. When it contracts, it dims. These pulsations may last for months, making Betelgeuse look dynamic in the night sky. Despite being such a massive star, Betelgeuse has a relatively low temperature of about 3,500 Kelvin. Because of this, it exhibits a distinct red hue, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in its final evolutionary stages. It has depleted the hydrogen fuel at its core and has begun fusing heavier elements. This fusion process generates energy, causing the star to expand beyond its original size. Betelgeuse's atmosphere is full of intricate physical phenomena, including dark magnetic spots on its surface where the magnetic field overpowers the surrounding area. These spots disrupt convection, preventing heat from moving freely. Despite these cooler regions, Betelgeuse remains an extremely active and vigorous star. Eventually, Betelgeuse will end its life in a stunning supernova explosion. As a massive star approaching its end, it will undergo a violent transformation, fusing heavier elements like carbon and helium. This process will cause the star to grow even larger before succumbing to a catastrophic explosion, a supernova, that will mark its demise. A supernova is a powerful event, briefly outshining an entire galaxy. Such an explosion could unleash shock waves through space. Scientists believe Betelgeuse may experience this fate relatively soon, though not immediately. Astronomers are diligently studying the star in hopes of learning more about its future and the broader evolution of the universe. When Betelgeuse eventually explodes, it will eject its outer layers into space. Its core could collapse into either a neutron star or, if massive enough, a black hole. A supernova of this magnitude will be visible from Earth without a telescope, due to its immense brightness and proximity to our planet. The explosion will release vast amounts of energy, producing heavy elements like iron and nickel, elements essential for the formation of planets and other celestial bodies. These materials will spread throughout the universe, enriching the interstellar medium and contributing to the formation of new stars and planetary systems. In recent years, Betelgeuse has displayed unusual fluctuations in brightness, leading to speculation that it may be on the verge of a supernova. However, despite these variations, scientists cannot determine exactly when it will explode. Some studies suggest it may happen within a few 100,000 years, an instant in cosmic terms, but still a long time on human timescales. The James Webb Space Telescope, JWST, has provided new insights into Betelgeuse, allowing researchers to study its outer layers and magnetic fields in unprecedented detail. These findings have confirmed the star's ongoing changes, including its irregular brightness and potential instability. Such observations provide valuable information about the final stages of a star's life, enhancing our understanding of stellar evolution. The death of Betelgeuse will have significant cosmic consequences. The shock waves from its supernova could trigger the formation of new stars in its surrounding region, advancing the cycle of stellar birth and death. The elements produced in the explosion will disperse across space, enriching the cosmos and playing a role in the formation of future celestial bodies. Betelgeuse's eventual demise will not only mark the end of one of the most remarkable stars in the night sky, but also pave the way for the next generation of celestial objects. Although we may not witness its explosion firsthand, studying Betelgeuse's final moments provides valuable insights into the life cycles of stars and the dynamic nature of the universe. Ongoing research into Betelgeuse, aided by advanced technology and space observatories, will continue to shape our understanding of astrophysics. By studying stars like Betelgeuse, astronomers gain a deeper comprehension of the forces that govern the universe and our place within it. These celestial giants remind us of the vastness and complexity of space, inspiring wonder and advancing our knowledge of the cosmos.